Here, let's start with the PLC programming of Siemens TI portal. Here we can create the analog input scaling, analog output scaling. Here we have, we want to create analog input output blocks. Now we selected two important blocks, is a limit block and one is calculated block. And we can create here analog input first, and then we can create the analog output block. First, we have to create some analog x minimum, x maximum, x y minimum, and maximum, and some tested value. Here we assign x minimum, x max, raw in tested value, and some output value. Here we need to create some uh, blocks. In that block, we have assigned the input 2 minus input 1, input 4 minus input 3, and bracket complete multiply by tester value, which is input 5. This is our basic functionality for the scaling. Um, this scaling is based on linear equation like y2 minus y1 divided by x2 minus x1 multiplied by m. This is our linear scaling functional uh, we are using for the scaling of the analog input output. We are going to set some minimum maximum limit for block. We just adding one greater than block and less than block for the limit. This tested value we have um, uh, that the raw input is our raw input from the PLC input card, and xmin and xmax is the uh, maximum and minimum value for the testing. And that after that this the raw input is moved in tested value, and then we can compare our raw input. If the raw input is greater than x max, then automatically we can move that x max in the tested value, because we want to avoid the over limit value move into the tested value. So we move that x max in a tested value, in a tested value, and then similar we can assign the great less than value also. That in minimum and maximum value, it should be in integer, because our input value, raw input value, is the integer. So that's why we need to select and that integer, that x min and x max is the integer, and our tested value, it should be is also in integer. The similar we can add for the raw in is less than x min. Now our complete analog input block is ready. Then we can use this block as a function block for the analog input. This calculated that out calculation formula is always constant for analog input and analog output, because scaling is always same. Here we can duplicate that in a AI block to create the analog output block. Now we just rename that AI underscore 1 to AO. The similar block we are using for analog output. It's the analog output block, function block. Now here some changes we need to do according the analog output, because when we transfer input from the PLC analog input card, that is in integer, and that conversion it may be in real or integer. Here we converted that integer into real value. It means the output value is our in real. And the similar case for the analog output, we are converting that integer and real value in integer when we want to transfer that output to the analog output card. So our y min, y max, we need to select as real, and then draw in also in real. Then raw, and we select as a real data type, and y min and y max is in real, and the tester value is also in real, because we are transferring that raw in value in real. So here greater than and less than is also in it should be in real, because our input and output is also in real. This is the analog input block. Then we can check in the analog input also we need to revert it, and then we can see the analog output is the real and analog input is the integer. That x max and x max is it should be in y max and y min. We just reverted that values. It nothing means the formula is changed, but the formula is basic concept of the formula is always same. It's nothing changed. We just revert that y and x. Just swapping in x and y. Or output value, it should be in integer for analog output block, because our analog output card in accept only integer values. It means the 16-bit boolean values. Here we can use that function block as analog input and analog output blocks. Just select the raw block, and here we can assign AI. It will automatically assign to the function block of AI. And the data DB, it automatically assigns when we create the data tag name for that AI block. We here suppose the tag name is AI DB00, then it will automatically assign to DB1, and then output we can assign to some any tag values we can create to assign that output. Otherwise we can left for now, we can assign later on. Then function block for output, take the small function block, then click here and select AO. Then AO function block is ready. Your two blocks for the analog input and output is ready. So we can create some virtual soft tags. That in the soft tag we can move some values that will be just for the reference purpose. We can create the some soft tags, and from that soft tag we can assign some values to the analog output block, and some raw input is coming for analog input block. Here we need to assign that hardware output address. See, we assign that hardware output address as a AO 1 underscore 00. That address is %QW128. See, here we can create some soft tags. For example, voltage output 1, the data type is real. For the real and real data type, that address we should to assign as a memory register is the MD200. We can assign memory address is MD200. Let's create the multiple tags as output 1, 2, 3. Give some comment or in discussion for this subtext. Is the voltage value. Go to the main block. Here we can move that value. At the voltage output 1 is to MD200. It moves to the analog output block to raw in. That raw mean x mean x max, y mean y max is by default we have set in the function block. Otherwise, you can set something else value in the DB. Okay, our program is little bit ready. Some hardware address is assigned to the raw in for AI block, which is IW128. That address sub tag is AI1 underscore 00. So we can download this program to the PLC, and my downloading is almost finished. There is no error, so our program is correct. It may be C, whatever changes we required. At the online we can test the functionality of the function block. If we get some error, then we can find out that error and we can resolve if we get some error. See, our program is online. We can assign some voltage input. See, we assign some voltage input to the voltage output that I'll directly assign to the output block, and that output block is converted that voltage into 27640. It's a digital voltage range 0 to 10. We that maximum value for 0 to 10 is 0 to 27640. And then similar value you can check with the analog input is reflecting or not. See here our conversion is taking okay. No any great if the voltage is raw mean is greater than some value, then it automatically transfer that maximum and minimum values. See here this tag is not taking value, then we need to check what happens. Some type, data type or like that we need to change or not. We can take the voltage input subtags to measure the input voltage from the analog input card. Some comment we can give as per our convenient. I think anything wrong inside here, or to see the value we need some tag to assign that output value, then we can see the value, what is value outside it showing. This soft tag we can assign to the output value, then we can easily see the output value. Tag description is voltage input value. See now it's transferring that input values, but it not showing the output value. So we need to check the block. Something wrong inside. Yeah, see here we, calculate block type we selected as integer, but it should be in real because we are converting that integer value in real. So we need to select that block as a real, then it will show the correct value. Change this name, calculate name as real. The data type is real. Then we can download, save and download. See the function block, we changed that AI function block. It is difference in the PLC and in the soft tag, so that's why it's showing blue and orange uh, light there. After the downloading, it will take reflect as green. Everything is green. It means the same program inside and outside. See, all the green button is there. See, you see that input value we transfer and output value it's showing the 4.999. It means almost 5 volt. It's done. You can follow my videos for the next tutorials of Siemens TI portal. Thank you.